Mathematics, Grade 9, First Term, Chapter 8, Angles related to straight lines and parallel lines. Objectives. By studying this lesson, you will be able to identify and verify the theorems related to the adjacent angles, vertically opposite angles formed by one straight line meeting O, intersecting another straight line, and use them to solve problems. Identify the angles formed when a transversal intersects two straight lines. Identify and verify the theorems related to the angles formed when a transversal intersects two straight lines and use them to solve problems. Let's see introduction. First, we are going to recall our memory in previous grades. Adjacent angles. The angles angle ABD and angle DBC in this figure have a common vertex. The common vertex is B. They also have a common arm BD. The pair of angles, angle ABD and angle DBC, lie on opposite angles of the common arm BD. Such a pair of angles is known as a pair of adjacent angles. Angle ABD and angle DBC are a pair of adjacent angles. Let's see complementary angles. If the sum of a pair of acute angles is 90 degrees, then that pair of angles is called a pair of complementary angles. Now you can see two angles, angle ABC and angle PQR. Now take the sum of these angles. Angle ABC plus angle PQR equals 40 degrees plus 50 degrees, we are getting 90 degrees. Therefore, angle ABC and angle PQR are a pair of complementary angles. Let's see supplementary angles. If the sum of a pair of angles is 180 degrees, then that pair of angles is called a pair of supplementary angles. Now you can see two angles here, angle KLM and angle PQR. Now take the sum of these angles. Angle KLM plus angle PQR equals 40 degrees plus 140 degrees. We are getting 180 degrees. So, angle KLM and angle PQR are a pair of supplementary angles. Let's see angles related to straight lines. Theorem. The sum of the adjacent angles formed by a straight line meeting another straight line is two right angles. Now you can see an example here. You can see two angles, angle AOC and angle BOC. Now take the sum of these angles. Angle COC plus angle BOC is equal to 180 degrees. Therefore, the two angles, angle AOC and angle BOC, are a pair of supplementary adjacent angles. The sum of the magnitudes of the angles on a straight line is 180 degrees. As an example, in this figure, four angles have been drawn at the point O on the straight line AB. The values of these angles in degrees have been donated by A, B, C and D. In a situation such as this two, we can say that the angles are on the straight line AB. So, it's clear that A plus B plus C plus D equals 180 degrees. Let's see exercise 8.1. Question number 1. In each of the following figures, AB is a straight line. Based on the information in each figure, find the value of the angle denoted by the lowercase letter. It's given AB is a straight line. We have already known the sum of the magnitudes of the angles on a straight line is 180 degrees. In here we can see two adjacent angles. What are they? Angle ACD and angle DCB. Therefore, we can get A plus 90 degrees equals 180 degrees. Write the reason here. Angles on the straight line ACB. Take 90 degrees to the other side. A equals 180 degrees minus 90 degrees. We are getting A equals 90 degrees. Question number 3. In the figure, ABC is a straight line. Based on the information given in the figure, show that angle PBR is a right angle. We have already known the theory. The sum of the magnitudes of the angles on a straight line is 180 degrees. Therefore, we can get x plus y equals 180 degrees. Write the reason. Angles on the straight line ABC. Then we can get 2x plus 2y equals 180 degrees. Now take the common factor, that is 2. Within brackets, x plus y equals 180 degrees. Now take 2 to the other side. X plus y equals 180 degrees divided by 2. Then we can get x plus y equals 90 degrees. So we can say angle PBR is a right angle. Let's see vertically opposite angles. The vertically opposite angles formed by the intersection of two straight lines are equal. In this figure, the straight lines AB and CD intersect each other at O. The vertex O is common to both the angles, angle AOC and angle DOB. Furthermore, there are on opposite sides of O. The pair of angles, angle AOC and angle DOB, are known as a pair of vertically opposite angles. So we can write angle AOC is equal to angle DOB. Similarly, angle AOD and angle BOC lie on opposite sides of O, which is the common vertex of these two angles. Therefore, angle AOD and angle BOC are also a pair of vertically opposite angles. So we can write angle AOD is equal to angle BOC. Accordingly, it's clear that two pair of vertically opposite angles are formed by the intersection of two straight lines. Exercise 8.2, question number 2. In the figure, the straight lines AB, CD and EF intersect at O. Based on the information provided in the figure, find the magnitude of each of the following angles. Part 1. Angle AOC. When we are getting these two straight lines AB and CD, the vertex is O. Then we can see vertically opposite angles. What are they? Angle AOC and angle BOD. It is given the magnitude of the angle BOD. angle BOD is equal 30 degrees. Then we have already known the vertically opposite angles are equal. Then angle AOC is equal to 30 degrees. What is the reason? Vertically opposite angles. Part 2, angle BOE. When we are getting these two straight lines AB and EF, we can see vertically opposite angles. Angle BOEN, angle AOF. It is given the magnitude of the angle AOF. It is 100 degrees. Then we can get angle BOE is equal to 100 degrees. What is the reason? Vertically opposite angles. Part 3, angle COE. We found the magnitude of the angle BOE is equal to 100 degrees. Then we can take angle COE plus 30 degrees plus 100 degrees is equal to 180 degrees. What is the reason? The sum of the magnitudes of the angles on a straight line is 180 degrees. They are supplementary angles. Then we can get angle COE plus 130 degrees is equal to 180 degrees. Then take plus 130 degrees to the other side. Angle COE equals 180 degrees minus 130 degrees. Then we are getting angle COE is equal to 50 degrees. Let's see corresponding angles, alternate angles and allied angles. First of all, tell me what is transversal? A line intersecting two or more straight lines is known as a transversal. In this figure, the two straight lines AB and CD are intersected by the straight line EF at the points G and H respectively. The line EF is known as a transversal. Let's see corresponding angles. Characteristics of the corresponding angles. Both angles should lie on the same side on the transversal. Both angles should be in the same direction with respect to the two straight lines. This is like F letter. Can you identify the pairs of corresponding angles? A and E, C and G, B and F, D and H. They are pairs of corresponding angles in this figure. Let's see alternate angles. Characteristics of the alternate angles. The two angles should be on opposite sides on the transversal. The line segment of the transversal, which lies between two straight lines, should be a common arm of the two angles. This is like Z letter. Can you identify the pairs of alternate angles in this figure? What are they? C and F as well as D and E. They are pairs of alternate angles in this figure. Let's see allied angles. Characteristics of the allied angles. A pair of allied angles are always on the same side of the transversal and they are in the internal area. What's the letter here? U or C letters, remember, for allied angles. Can you identify the pairs of allied angles in this figure? What are they? C and E, D and F. They are pairs of right angles in this figure. Exercise 8.3, question number 1. Consider the figures given below of two straight lines intersected by a transversal. By considering the angles represented by the lowercase English letters in the given figures, fill in the blanks. Part 1. In figure 1, A and B form a pair of which angles are there? This is like letter F, corresponding angles. Part 2. In figure 2, C and D form a pair of which angles are there? Alternate angles. This is like letter Z. Part 3. In figure 3, E and F form a pair of, we can see, right angles. This is like letter U. Let's see angles related to parallel lines. When two straight lines are intersected by a transversal, if a pair of corresponding angles are equal, a pair of alternate angles are equal, or the sum of a pair of allied angles is 180 degrees, then the two straight lines are parallel to each other. This theorem is the converse of the theorem learnt earlier. When a transversal intersects a pair of parallel lines, the corresponding angles formed are equal. Then we can say C equals G, D equals H, as well as E equals A, F equals B. Part 2. The alternate angles formed are equal. That is like letter Z. We can say D equals E, C equals F. Part 3. The sum of each pair of allied angles formed equals two right angles. Two right angles means 90 degrees times 2. We are getting 180 degrees. Then we can say C plus E equals 180 degrees, as well as D plus F equals 180 degrees. Exercise 8.4, question number 1. In the figure, AB is parallel to CD. If angle PRB equals 50 degrees, find the magnitude of each of the following angles. Part 1. Angle RSD. We can see corresponding angles. What are they? Angle PRB and angle RSD. It is given the magnitude of the angle RSD. That is 50 degrees. Then we can write angle RSD equals 50 degrees. What is the reason? Corresponding angles. Part 2. Angle ARS. We can see vertically opposite angles. Vertically opposite angles are equal. Then we can write angle ARS equals 50 degrees. Part 3. Angle CSQ. Then we have already known the magnitude of the angle RSD. Then we can get angle RSD and angle CSQ are equal. What is that? They are vertically opposite angles. Then we can write angle CSQ equals 50 degrees. Part 4. Angle QSD. Then we can see supplementary angles. What is the value of angle QSD? We found 50 degrees. Then we can take 180 degrees minus 50 degrees, 130 degrees. Angle QSD equals 130 degrees. Mathematics, grade 9, part 1, Exercises. Review exercise. Exercise 8.1, Exercise 8.2, Exercise 8.3, Exercise 8.4 as well as miscellaneous exercise. Now you can do these exercises. These exercises are in your textbook. Thank you, children.